We're going to look at the 2025 free response questions for the AP Calculus exam. And I am reading these questions for the very first time. They were just dropped a few minutes ago. I have not polished an answer up yet, so you may see me make mistakes here. You're going to see me maybe pause and think about the problem a little bit. All I know about this question is that it is a common question for AB and BC, and this is a calculator active question. So let's look at it. You'll see an invasive species of a plant appears in a fruit grove. It begins to spread. C is given there. It is the number of acres in the fruit grove. So I'm going to make a note to myself, C of T. So C of T is the number of acres in the fruit grove. T is weeks after the species appears, and they also give you C prime. That's nice of them. Okay, so find the average number of acres affected by the invasive species from 0 to 4. Okay, so it's number of, okay, so the average, this is an average value theorem question. So question A, they give you the function C of T, and they want you to find the average value of C of T. So we're just going to do the average value theorem. This is from 0 to 4, so that's 1 over 4 minus 0, antiderivative of the function C of T. Put that dt in there, and this is from 0 to 4. So you definitely want to write that setup, and the next thing I will write down is the answer. But first, I have to define my function. And so I'm going to come over here, and I'm just going to use Scratchpad. You can use a document if you want to. I tend to live on Scratchpad. So I'm going to do C of T is equal to, and that is 7.6 arctan. Does that work? Yes, it does. 0.2 T. That is entered correctly. And then C prime is also given, I'm going to call that CP of T for C prime of T, and that is given as 38 divided by, so 38, that's not an 8, 38 divided by 25 plus T squared. Double check that, make sure everything is incorrect. I am in radian mode, and I need to compute the average value of C of T. So that's going to be 1 over 4 minus 0, shift plus 0 to 4 of C of T dt. Enter. And you get 2.7782. You only have to be accurate to the third decimal. 2.7782. But I always like to write the fourth just for fun. All right. That's it for question A. All right. Question B. Find the time t when the instantaneous rate of change, that's C prime, so I'm going to write as I read, the instantaneous rate of change of C would be C prime of T is equal to the average rate of change from 0 to 4. This is your mean value theorem. So I'm going to set it up. The average rate of change of C is C of 4 minus C of 0 over 4 minus 0. Is that right? So the instantaneous, where am I? I'm really close to the camera. The instantaneous rate of change of C equals the average rate of change of C, not C prime. Show the calculations. Okay, so there's our setup. I'm going to compute C of 4 minus C of 0 over 4 minus 0. So let's do that real quick. C of 4 minus, that's not a 4. C of 4 minus C of 0 over 4 minus 0. And I'm getting 1.282. I'm going to store that in my calculator as the value A, because I'm going to use that answer in just a minute. So 1.282, so we need C prime of T to equal 1.282, and I'm just going to make a note to myself so I don't forget that A is 1.282. That's just a little thought cloud to myself. And then I'm going to solve that in the calculator by graphing, and I'm going to graph C prime, because I want the instantaneous rate of change to equal that value A. And we are on the interval. Let's double check the intervals here. On the interval 0 to 4. And so we're looking at that intersection right there. So menu, analyze, intersection. And I'm getting 2.1. Oh, that is dangerous. I'm only seeing 3 decimal places. I should see more than that. Or 4. I don't like that. There, let's get a few more. So 2.1543. So that happens at T equals, what did I say? 2.154, and it's actually 29. But there's your answer for B. Make sure I answered the question. Find the time t when these temperature changes. Okay, that's good. Assume the invasive species continues to spread according to the model for all values of t. Write a limit expression that describes the end behavior of the rate of change. This is a calculator question? Evaluate this limit expression. Wow. I'm surprised this is a calculator question because, anyway, all right. Write a limit expression that describes the end behavior so that's what's happening as t goes on to infinity. So that is the limit as t, the very far right end. What happens is we just keep going on and on and on and on and on and on and on, and we are evaluating the limit of c prime, correct? The rate of change in there. So that's going to be c prime. And because I'm going to evaluate this limit, I'm going to actually write the c prime expression. That's 38 divided by 25 plus t squared. And my calculator can actually compute that limit. That's not a difficult one. The bottom degree is larger than top degree. No trickiness there. Then D, at time t equals 4 weeks after the invasive species appears in the grove, measures are taken to counter the spread of the species. Okay. The function A is given by that expression. Is the number of acres affected from 4 to 36. Okay. At what time does A attain its max? Okay, this is extreme value theorem. We have a closed interval from 4 to 36, and we have a function for A of t. I'm going to work that over here, give myself a little bit more room, move my head out of the way. So A of t is C of t minus the antiderivative from 4 to t of 0.1 times the natural log of x dx, okay? So there's my function A, and I need to consider critical numbers and endpoints, so I need to know what A prime of t is, and A prime, the derivative of c is going to be c prime of t. The derivative of this integral expression will be 0.1 times the natural log of t. And then I need to set that equal to 0. So I'm going to say A prime of t is going to equal 0 when t is equal to what? And I'm going to go back to my calculator, and I need to graph c prime minus that expression. So back to my calculator. I'm going to go up here. I'm going to just clear these two things out. I don't think I need these right now or anymore. So go up. Let me clear this one. So it's c prime, I'll just keep that in there, minus, and the derivative of the other expression was 0.1 times the natural log of x. Enter, and I want to look at this on the interval 4 to 36. I'm going to go menu, window, settings. I'm going to change that to 4 to 36. Okay, and we have good. We have the one critical number. So analyze, intersection, not intersection, escape. Menu, analyze 0, and I'm getting that. I don't know why my calculator's only, it's dangerous to have 4 decimal places shown. So 11.4416, so 11.4416, I'm going to store that for B. And there are a couple of ways you can finish this problem. If you look at this derivative graph, this is the graph of A prime, and I can see that this A prime changes from positive to negative, therefore this is going to be a local maximum, and based on the intervals of increase, decrease, you can conclude that that t value is the t value where A will achieve its absolute max on this interval. However, in an extreme value theorem, I usually find it a little bit easier to justify or support your answer by simply computing the value of the given function A of t at all of our candidates, which will be the left endpoint of 4, the midpoint, the critical number at B, and then I'm going to evaluate A of 36, is that right? A of 36. And then I'll simply see what the values are at each of those. And so I'm going to go here and go back to this spot. Let's see. So I'm going to define A of t. Ooh, why is A? Oh, because A is stored. Okay. Well, son of a stink face. All right, I'll just do this. It's c prime of 4 minus the antiderivative shift plus 0 to 4. I'm looking at no. It's 4 to 4. That's just going to be 0. I am wasting my time. 0.1 times the natural log of x dx. And that will be A of 4. That is 0.9268. And then I'm going to compute that same integral from 4 to my critical number of b. And the way I do that, I'm just going to go in here and did I not store that for b? I guess I did not. No, I didn't. So I'm going to store that, control store b, enter. There, now it's stored. And let me erase this. There. I needed the b to be bold. That's how the Inspire tells me that something is stored. I'm going to hit enter, and that value is negative 1.246. Okay, I have an issue with that. I have made a mistake somewhere. The graph is asking, so it's C. Oh, it's C, not C prime. There's my error. Yeah. Okay. So I need to do C, not C prime. So I'm going to go back here, and we'll just recompute this for C of 4. Recompute. Whoops, that's not what I wanted. Recompute this one for C of B. There we go. I was expecting that critical number to produce the maximum, so I'm really glad that I got that negative number, because that wouldn't have caught my mistake otherwise. So 5.128. 5.128. This is 7.3169. And then finally, we will compute that same function at 36. So let me go up, change that to a 36, go back here, change this to a 36, and I'm getting 1.743. And so as expected, the critical number was indeed the location of the maximum. Now let's make sure we answer the question. The question says, at what time t does A attain its maximum? It's not asking for the actual maximum value, it's asking for the t value at which A achieves its maximum. And so I'm going to type this out. A of t achieves its maximum value at t equals b, and b is 11.416 on the interval for less than t, less than 36. And there we are done with question number 1, I think. Yep, that is it. So if there are any mistakes, if you think I am wrong, comment, and I think I'm supposed to say like and subscribe. Do y'all do that? Should I do that? How do I end this recording? Ah!